In this video, we will be implementing a loss function for our network, and more specifically, we will be implementing the mean squared error loss function. And so let's go ahead and open the MSCL loss editor, and MSCL stands for, actually I think I'm saying it like a Portuguese person would, so MSE loss function. MSE stands for mean squared error, and what it does is it finds the errors between respective components of the two vectors, squares them, and then computes the mean. It just does what it says. So mean squared error loss function, we find the errors, square them, and average them. Wait, that's not how you spell it. Average them. Let's say that omega is the network output, and let's say that alpha is the correct targets. And so to find the differences, we just subtract them, and then we square them, except we are going to switch because we don't want to use parentheses, and then we need to average this. How do you average this? Well, you divide by the number of numbers you have. So let's divide. And again, we are dividing the right-hand side by the left-hand side, so we need to switch again. And then in here, just a little parenthesis to tally the number of elements that omega has. Actually, these will be column vectors, so we can just tally them like this. Or can we? Actually, we can. Yeah. So let's go ahead and leave it like that. So this is the mean squared loss, basically. If you press escape, you will close the editor window and save it. Let me go ahead and test it. Let's say that our network output was 0.30, and this is a column vector. And the actual target was, let's say, 1, 1. So the error is this. Oh, of course, I forgot, when you average something, you sum all the elements. Oh, I didn't mean to erase that. When you average something, you sum all the elements, and then you divide by the amount of numbers you have. So let's do this. Yeah, so it's right here. So I'm squaring them, and now I should sum all of them. And that's this, if you recall. This is summing things, except now, yeah, I recall this correctly. This is a column vector, and if you sum a column vector, here's what happens. You're going to sum, let's say this, it should give 1, right? Except it doesn't, because it's taking, because this is a vertical thing, it's summing across the rows, and the rows have nothing else, so everything is just left unchanged, except in a vector instead of a column matrix. So what we need to do is, when you have the column vector, we need to use comma to turn this into a regular vector again. So see, table 100 gives you a column vector. If you use the comma, then it becomes a vector, and then you can sum everything. Of course, you could also use reduce first if you know what that is. You can find it over here, but that's not necessary. Let's keep it simple. For newcomers to APL, that is. If you know your way around APL, you should do this properly. And so maybe this is becoming long for newcomers, so let me just, so the squares are the power of the differences, and now we can just sum everything and then make it more clear by dividing by the number of squares. So this is what is happening. If you save it, let's go ahead and try this again, and now it works. So the mean squared error between 1, 1 and 0.30 is 0.745. If I make these numbers closer to 1, the error should decrease, and if I make these numbers equal to 1, the error should be 0. So there you have it.